Hello friends, welcome to my channel. And in the last video, in this where I have solved this 2022 paper of physics, c-5 mathematical physics BSc third sem, right? And I left few questions because you had an exam. Before exam I had to upload that video because of lack of time. I left few questions, and today I'm gonna complete this paper. So paper will be completed in this video. So please share with your friends and help me to grow my channel and keep watching my videos. And if you are new to my channel, please subscribe the channel. Also hit the bell icon so that you get notified when new video will be uploaded. And please help me to get previous year's questions papers, okay, as many as possible. So if you have previous year's questions papers of fourth semester, then please let me please help me to get that paper. So this is my Insta ID, Lakhyajit 123. This is my Insta ID. You can message me, and I'm gonna give you my WhatsApp number or email ID, so you can send me the PDF. Okay, I will give you the email ID. You can send me the PDF. Okay, if you have questions papers, previous year's questions paper, so I can help you. Okay, so now let's start. So in the last part, I have solved question number 5A and B. Now I left this question 5C. Okay, today I'm going to solve this one first, and then I'm going to solve two more questions that those were left out. Okay, I'm going to provide you the links of those videos, previous videos, previous parts, first part 1, part 2. Okay, so now let's start. So here we need to find, first we have to write the definition, what is standard deviation of data, and then we need to calculate standard deviation of this series, right? So let me give you the answer. So this is the definition of standard deviation, and we need to find the standard deviation of given data, and given data are here, these are the given data: a plus d, a plus twice d, a plus n d. So that is this is the data we have here. First let us find the mean. So first, what do we need to find? We need to find the mean of this data. So how to find the mean? If you see, you can consider this one as a plus 0 into d, right? And then this one is a plus 1 into d, and so on. This is a plus n into d. So from this term, from 1 to n, there are n number of terms, and including this, there are n plus 1 number of terms. Okay, so hope you have understood this. So that's why, let me clean these things. Okay, so now, so sum of all these. So sum of this, here you see these numbers are in AP, so we can use the formula to find the sum of nth term of an AP, that is n by 2 twice a plus n minus 1, but here we have n plus 1 number of terms, n plus 1 minus 1 into d, right, into d. Now divided by, if we divide this sum by the total number of terms, that is n plus 1, then we can get the mean, right? So now as we have n plus 1 number of terms, that should be n plus 1, right? Because we know that Sn is equal to n by 2 twice a plus n minus 1 into d. This is the sum of an AP, sum of nth term of an AP. Okay, so now you see, this is the sum of first n terms of an AP. So here we have, including a, we have n plus 1 terms, so that's why replace the n by n plus 1, right? N plus 1, and divide the sum by n plus 1, then you're going to get the mean, right? So now let me clean these things. Okay, so now if you simplify this, then what you're going to have here, n plus 1 cancels, right? So then if you open the bag to half into a, so 2 to cancel, so you can write simply a, then plus, this is plus 1 minus 1 gone, and into d by 2, right? So that's what we're going to have. So this is the mean, right? So now let us assume a mean. Let a is equal to assume mean. So we have assumed a mean. This is assume mean. So now we need to find sum of xi minus a. Right, sum of xi minus a. So if you subtract a from the first term, then you're gonna have 0. Then plus, if you subtract a from the second term, you're gonna have d, then twice d, then thrice d, and plus dot 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 dot, so on up to nd. That's what you're gonna have, right? So now take the d common. If you take d common, then what you're gonna have, 1 plus 2 plus dot 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 up to n into d. So sum of first n natural number is given by n into n plus 1 divided by 2, and we have d here, right? So now let me copy these things and let me go to the next slide. First let me copy the mean. This is the mean that we needed, and this is the mean here. Let me write this one here. Then let me write this sum also. Just wait. And this one, so let me take this one as well. Okay, let me go to the next slide. Yeah, you can see. Then let's find sum of xi minus a whole square. Okay, so if you find that, then what we're going to have, what are the given data here, you can see. You can see, so xi minus a is this is the xi minus a, right? Let me copy this, xi minus a. So simply this is the xi minus a. We need xi minus a square. That means square of this, square of this, and square of this, square of this, and square of this. That's what we needed, right? So if you take again d common, then you're gonna have 1 square plus 2 square plus dot 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 plus n square into d square. That's what you're gonna have. And the sum of the squares of first n natural number is given by n into n plus 1 into twice n plus 1 divided by 6. Then we're gonna have d square here, right? So this is our sum of xi minus a whole square, right? So now how to find a standard deviation? Standard deviation is given by root over 1 by n plus 1, because we have number of rounds is 1 plus 1, n plus 1, then summation xi minus a whole square, then minus summation xi minus a divided by n plus 1 whole square. So this is the formula to calculate standard deviations. Okay, now we're gonna put this value here. So then what we're gonna have, so now let me go to the new slide. Just okay, let me try to adjust here. Just wait. Okay, just wait, let me break this. Okay, here we go. Just wait. Okay, so here let me find more space. So now root over, now you see, let us replace this one by this result. Now let me copy this. So that's what we have got here. We have 1 by n plus 1, right? Then minus root over, and let us replace this by this result. Okay, so that is what? That is n into n plus 1 divided by 2 into d by again n plus 1 and whole square. That's what we can have. So here you can see n plus 1 gone, right? This two gone. So now here also this n plus 1 cancels. So this is our standard deviation. So now let me copy this and let me go to the new slide. So we have done enough here. So yeah, so after simplification, what we're going to have, root over n into twice n plus 1 by 6 and this d square, and from here we can take 1d square common. So out of the square root it's going to be d only, so d square is taken common and taken the square root of that. Then here n square by 4, that's what we're going to have. Then you see, just let me clear this. So now let us simplify. D root over, and if you take LCMs and simplify, then what you're going to have, the 12 will be the LCM here. Then here 4n square plus twice n minus thrice n square. Then after simplification, what we're going to have, we're going to have n square plus twice n divided by 12. That's what we're going to have. So this is our answer. So hope you have understood this. Now let's move on to the next question. Now we will solve question number 6.1. These two are already done, okay, in the last part. So I left this question. So now let me solve this one first. Let me go to the new slide. Now here you see, if we have u here, then make this variable u. Okay, so there must be a printing mistake. Okay, so here is the given equation and conditions. So now what we can do, let us take u is equal to capital X, which is a function of small x, and into capital T, which is a function of small t, right? So let me take that one. So this is equation number 1, suppose. Okay, so now let's find del u by del x, right? Then take the t as a constant, then you can have d capital X by d small x. Then let's find second order derivative. Let us differentiate this again partially with respect to x. Okay, so then again you're going to have t d square x capital X by d small x square. That's what you're going to have, second order derivative of capital X with respect to small x. That's what we're going to have. So now similarly, let's differentiate this with respect to small t partially. Then we're going to take this time x as a constant, then d capital T by d small t. Then if you differentiate it again, then you're going to have this second order derivative of u with respect to small t partially. If you differentiate, then you're going to have this result, right? Now let us use these values in this equation. Okay, so using these results in the given equation, then what we're going to have, then our equation is turned out to be like this. This given equation gonna be of this form. Okay, this is replaced by this. Then on the other side of the equal sign, this is replaced by this. Right, So hope you have understood this. So now let us separate the variables. So how to separate this? So bring the x on the same side of the equal sign, and shift the t on the other side. Okay, so then what we're gonna have? 16 capital X, second order derivative of capital X with respect to small x, then here 1 by capital T, then second order derivative of capital T with respect to small t. That's what we're gonna have, right? So now let it be minus p square. Okay, let's say minus p square. So now let me copy these things and let me go to the new slide. So here is the last step we have got, and so here we can write that 16 by capital X, second order derivative of capital X with respect to small x is equal to minus p square. And if you simplify this, then it can imply 16 second order derivative of capital X with respect to small x, that's going to be minus p square into capital X. So if you bring it to this side of the equal sign, it's going to be positive, right? Positive p square capital X is equal to 0 on the other side, and it can be written in this way. 16 d square represents this differential coefficient, right? And this x take in common, then we can say into x is equal to 0. So our auxiliary equation is going to be 16m square plus p square is equal to 0, and that's gonna give you m square minus p square by 16, and square root of that gonna be plus minus root over p square by minus p square by 16, right? So here minus p square by 16 can be written as this, minus p square can be written as ip whole square by 16, right? And square root of that gonna be I p by 4, right? So we have got two roots. M is equal to I p by 4, and another is m2 is equal to minus I p by 4. So here roots are imaginary, so we are getting imaginary or complex roots. When your roots are of this complex form, alpha plus ib, m1 is suppose alpha plus ib, and m2 is suppose alpha minus ib. In that case, what should be your solution? Solution should be of this form. The solution is given by c1 cos cos beta x, if the variable is x. Okay, so then plus c2 sine beta x, and this is into e to the power alpha. Here alpha is 0. Here we are getting 0 plus ip by 4. You can imagine that with 0 minus ip by 4, right? So here alpha is 0, so this term going to be equal to 1, right? So here let me clean these things. So if this is the form, then what going to be the solution? So solution of this equation will be then in terms of x. So let me write this one here. X is equal to, now we have got that c1 cos p x by 4, then plus c2 sine px by 4. Beta is p here, px by 4. That's what we're gonna have, right? So this is the solution of x. Now let's find t. Let me take this part of this solution. Okay, so then what we can write, just wait, let me adjust these things. So here you see, let me go to this part. So 1 by t, second order derivative of capital T with respect to small t is equal to minus pt square. So this is going to be, if you simplify this is going to be of this form. right? Then it can be written as, d square plus p square into t is equal to 0. So here auxiliary equation is going to be of this form: m square plus p square is equal to 0. And if you solve it, then you're going to have plus minus p, right? Sorry, ip, not only p, plus minus ip, right? So in that case, again we have got complex roots. So here the solution is c3 cos, here beta is p now only, px plus c4 sin px. That's what we have got. So we have got x and we have got t. So let us use these two here in this equation number 1. Okay, then we're gonna have u, right? So let me copy this. So here we're gonna use, here say I made a mistake here, that should be t actually. So here it should be t. Okay, so now let us use these two results in the first equation here. So let me go to the new slide. So using these results in 1, so 1 implies u, this is you see, you can write this one as u of x and t, right? So u as a function of x comma t, so that's going to be equal to, we had capital X, which can be replaced by this value of x. You see, it can be replaced by this value of x, right? And capital T, this can be replaced by this value of t. Then what you're gonna have? Then you're gonna have this result, right? So again, that given condition is that u of x comma 0 means here t is equal to 0. If you put t is equal to 0, then you should get x square 5 into 5 minus x, right? X square into 5 minus x. That's what that is the condition given in the equation, in the question, right? So that was the condition. So now you see what gonna be the result now. So if you put t is equal to 0 here, then what you will get? So sin 0 gonna be 0, right? So our result will be, and cos 0 will be 1. So that's why we're gonna have c1 cos p of x by px by 4 plus c2 into sin px by 4. Let me write this, sorry, just wait, this is c2. Okay, here we're gonna have c3 only, right? And x square 5 minus x, that's what we're gonna have. So now here you see c2 cos px by 4 plus this should be c1, then c2 sin px by 4, that will be equal to x square 5 minus x divided by c3. That's what we can have. This is suppose equation number 2. If I have used 2 here somewhere, not. So this is equation number 2. Now let me use this equation here. You see, just wait. So let me give this is 2 and make it 3. Okay, so using 3 in 2, okay, using 3 in 2, okay, just what we need to do, we need to replace this part by this value, right? By this value, then what you will get? Just wait, let me simplify one more step here. So that is what we can do here. We can find we don't need this step. Okay, just wait, let me keep it that way. So this is suppose 3. So here you see, from equation number 2, what we're going to have, u is equal to, if you multiply this two, then what we're going to have? We're going to have 3 c3 cos pt is into c1 cos px by 4 plus c2 sin px by 4, and then plus we can have then again if you multiply this one with this, then what you will get, c4 into c1 cos px by 4, then plus c2 sin px by 4. That's what we're gonna have, right? So now let me copy this result and let me go to the next slide. Okay, just wait. So this is sin pt. I missed this. Now here you see we have got c3 into this is equal to this. So this is c3 and this is this one, right? So we can replace these two by this expression. Then you see, using 3, what we can do, just replace this c3 into this by this value, right? So then what you will get, cos pt and into x square 5 minus x, that's what you're gonna have, plus c4 c1 cos px by 4 plus c2 sin px by 4. That's what we're gonna have. Sorry, I missed this sin pt. So that sin pt is there, I missed that. There should be a sin pt, right? So because here you can see I have multiplied these two, right? So when you multiply this one with this term within whole bracket, then you should get 4 sin pt into this, right? So here sin pt is left out, so let me put here sin pt. Okay, just wait. Sin pt. So this is the result. Now we have one more question. Actually there are two questions here, or so I thought that I could solve complete this paper in this single video, but these two are long. These two gonna take time, so I don't want to make this video very long. So wait for the next part. When the next part will be uploaded, that's gonna be appearing at the end of this video. Okay, that's gonna appear at the end of the screen. Okay, so stay connected and support me to grow my channel and help me to create new and inspire me to create new contents for you, and help me to get better reach. Okay, so see you in the next video.